we will practice expressing observational findings in mathematical language. The objective is to accurately and concisely represent what can be described in everyday language by using equality and inequality signs. Mathematics is a rigorous discipline. Rigor implies exhaustively determining whether a carryover exists from neighboring place values. When expressing the observations of each place value mathematically, one must essentially incorporate the influence of adjacent places. When the student explains using everyday language, facilitate their thinking by asking, "How would you express that using mathematical symbols?" If the inequality sign is unfamiliar to the student, first, clarify the concepts of greater than or equal to and less than or equal to in everyday language before introducing the symbol. Promote mathematical rigor by asking, if there is a carryover from the neighboring place, how does it affect the calculation in this place value? If the student provides an answer without a clear rationale, make sure to ask, why did you determine that? Let's try our best to share what we found in each place, using math language.
I'll start with the thousands place. It's t minus w equals 1. There is only one part in the thousands place, but the whole is different. This means there is a carryover from the hundreds place. Since we are adding two numbers together, the carryover has to be 1. If you add w and h in the hundredths place, it is 10 or more. That's because there has to be a carryover from the hundreds place to the thousands place. For the tens place, a equals 9 or 8. The part o in the tens place is exactly the same as the whole. This means if you add a to the carryover from the ones place, it becomes o. But there are three numbers in the ones place. If you add three numbers, the carryover can be 1 or 2. If you add w and a in the ones place, it makes 10. Since the part t and the whole t in the ones place are the same, w plus a must be carried over. So, w plus a equals 10. Then, a equals 9, and w equals 1. T equals 2, and h equals 8. Since there is a carryover from the tens place to the hundreds place, 1 plus 1 plus h is 10 or more. But 9 is already used, so h must be 8. O equals 0.
Wow, you're amazing! You really understand what we've learned so far. You explain the hundreds place by saying, adding w and h is 10 or more. Did you use everyday words instead of math language for this?
I couldn't write it clearly in math language, so I just used words to explain it.
Do you know the equal sign?
Yes. The equal sign shows that two things are exactly the same.
Then, how would you write adding 3 to 2 makes 5 in math language?
It's 2 plus 3 equals 5.
This time, let's think of an example where two amounts are not the same.
Let's say there are 3 items and 2 items.
Can you compare the two amounts?
3 is more than 2.
Great job! We can also say 2 is less than 3, right? Can you tell me the difference between those two sentences?
Your sentence compares them starting with 3, and my sentence starts with 2.
What if we combine same and more into one word?
It's or more.
That's right. In math, we put the greater than sign and the equal sign together. When you write it like this, it means greater than or equal to, which is just a math way of saying or more. Then, should we try writing what you found in the hundreds place using math language?
It is W plus H is greater than or equal to 10.
Spot on! In everyday words, it is adding W and H is 10 or more. But in math language, it is W plus H is greater than or equal to 10. Why did you write W plus H is greater than or equal to 10 for the hundreds place?
Because there's a carryover from the hundreds place, so W plus H must be 10 or more.
Let's look at an example, like 27 plus 38. If we add the tens place first, what do we get?
It's 6. Because there's a carryover from the ones place, we have to add 1 to 2 plus 3.
That's right. Whenever you look at a place value, you always need to check if there's a carryover from the neighbor on the right. Did you check for a carryover from the tens place when you looked at the hundreds place?
Oh, I didn't think about that.
Math is all about being precise. That means we have to look really carefully so we don't miss anything. The hundreds place changes if there's a carryover from the tens place. Can you try writing it in math language again, but this time include the neighbor?
It's 1 plus W plus H is greater than or equal to 10.
Perfect. And if we subtract 1 from both sides, we can write it even simpler. W plus H is greater than or equal to 9. Now, let's put together everything we found for each place using math language. You already told us the reasons, so you can just read the math sentences.
T minus W equals 1. W plus H is greater than or equal to 9. A equals 9, O equals 0. W plus A equals 10. W equals 1, O equals 0, H equals 8, A equals 9, T equals 2.
Organize what you observe in each place value step by step. Write an observation log. Write down the observations in math language, but explain the reasons using everyday language. Interpret each place value by always checking for carryovers from neighboring places. Why didn't you write it in math language? Translating spoken words into symbols is the first step in mathematical expression. Students need to feel the limits of everyday language themselves to truly understand why we need math symbols. What if we combine same and more into one word? This question pulls the concept of or more naturally from everyday language. Instead of just giving them the symbol right away, we start with words the student already knows. It's about connecting familiar ideas to symbols, not just memorizing them. When you looked at the hundreds place, did you check for a carryover from the tens place? Instead of pointing out the mistake directly, asking this helps the student realize what they missed on their own. Mathematical precision isn't just taught, it has to be felt and understood by the student. Great job finishing Lesson 6. Before moving on to Lesson 7, watch the logic flow lesson linked to this series. It will help you understand the next steps much more clearly. Check out Logic Flow Lesson 3 below.